Find the derivative of f of x, function of x equal to x squared from first principle. So now this question it deals with differentiation from first principle. This is the first question on differentiation from first principle in calculus. So now, before we bounce on the question, let's quickly do the recap of what we have been taught or what we have done in the proving of differentiation, in the proving of gradients and the derivative functions. Now we know that the formula for gradient is changing y divided by change in x. That means change in y-axis over change in x-axis. The change in y is, the formula is y2 minus y1 divided by x2 minus x1. So don't forget, it has a graph like this, and the curve is like this. So, and we draw a secant line along it. So if this place is 0, this way is x1, and this place is x2, while this place is y1, while this place is y2. So our gradient is changing is y2 minus y1 over x2 divided by x2 minus xy. That is changing y over changing x. We already know that that means our x2 minus x1 is the same thing as changing x. But what's there is that this our changing x will never be equal to 0 because this x2 and x1 they are not the same value. If they are the same value, that means our change in x will be 0, but they are not. For example, if x2 is 1 and x1 is 1, that's it, they are the same value. Then 1 minus 1, our change in x will be 0, but it's not like that here. So the x2 and x1 will never be the same, will never be the same value to achieve our change in x along the x-axis. Now, since they are not the same, our change in x will never be equal to 0. So therefore, we are going to make that x2 the subject of the formula. X2 is equal to this change minus x1 will come here. So to make our x2 the subject of the formula, if it come here, it is changed to plus x1, which is x1 plus change in x, or you can say change in x plus x1, vice versa anyhow, because multiplication, addition and multiplication are commutative in mathematics. 1 plus 1, 2 plus 1 is the same thing as 1 plus 2. x1 plus change in x is the same thing as change in x plus x1 anyhow. Now, if the case is like this, our x2 is equal to x1 plus change in x, but don't forget our y, the equation of this curve is y is equal to f function of x. That means this function of x is the same thing as this y. They are the same thing. So that means our y can also be f. This s can be x1, and it can also be, if it is s1, it will be y1. So y2 will be function of x2. They are the same thing. And don't forget, this x2 is the same thing as this value. They are the same. So therefore, we are going to do it like this here. So y2 is equal to, instead of writing function of x2, we are going to change it to x1 plus change in x, because this is the value of x2 here, x1 plus change in x, and it was written here. We are going to replace it with this value. So therefore, our y2 is this. Likewise, but our y1 is equal to, and sorry, it is function of x. Let me rewrite it because of, so that means our y2 will be function of x2 here, which will be what? x1 plus change in x. So that's it. But our y1 is f of x1. So therefore, our gradient will be change, which is change in y over change in x before, which is y2 minus y1 over x2 minus x1. So this y2, this is the value of y2, y1, this is the value of y1. So we now insert it y2 is f of x1 plus change in x minus our y1 is f of x1 divided by the change in y. So this is the formula we are going to apply for treating. This is the differentiation from first principle formula. So for treating differentiation from the first formula question, this is the formula we are going to be using. So now let's go back to the question. Before we move on, so let's talk about function. What is function? A function is a mapping whose codomain is a set of numbers. For example, if you are given a mapping defined by the diagram below, so this is a mapping, and we have this place is the domain, while this side is codomain. So, and the variables here is 2, 3, 4, and 6. Each variables here in the domain, each value of domain, they have their own image here. For example, if the image of these two here in this, so this is function f. This place is y. So now, if the image of these two here is 5, the image of 3 here is 7, the image of 4 here is 9, while the image of 6 here is 13. Now, what is there is that, for example, if you take your calculator and you press 2 plus 2, you give it 4. That 4 is the image of 2 plus 2. It's what reflect out. So that means this 2, this is the image of 8. This 3, image of it. That means this x, so the moment we apply a function to this x, that means f of x. So f of x of these 2 is 5. F of x of this 3 is 7. F of x of this 4 is 9. The f of x or function of this 6 is 13. That means our f of x is the same thing as y. Our f of x, what we get for the functions of each value here is also y. That means the function of 2 here is 5. That means our f of x, our function of x is the same thing as this y, because these are the values of the y we get. This y are the results of the function of x. That means function of x is the same thing as y. Now, for us to get this function, now what we want to discuss here is that what is a function? Because this mathematical setup is what we call a mapping. So we are still coming there. Mapping is a topic on its own. So it's a mapping. So now a function is a mapping whose codomain, this is codomain, this is the codomain, this is domain side, this is the codomain side. A function is a mapping whose codomain is the set of numbers. So there are some mapping that their codomains are just letters, they are not numbers. But any mapping that its codomain is numbers, full of numbers, that mapping is known as functions. So, and I'll explain this f of x. This x is going to be subjected to functions and this function of x is going to give us all the values here, which are the values of y. That means our function of x is the same thing as y. Now, to get our, similarly, if we write f3 here, function of 3 here, it gives us 7. It gives us y, which is 7 here. Function of 4 here, it gives us 9. Functions of 6, it gives us 13. While the function of the first function of 2, function of 2, it gives us 5. So to calculate all these functions, how do we get about it? How is it possible like that? It is possible by what the formula that is used in deriving or in getting this codomain from domain. So if you observe very well, this f of x, which the functions of this is, it leads to the codomain. It gives us the codomain by multiplying all this x, or the value of this x by 2. And adding the result by 1. If you check very well, these two times this x now is 2, yes. So let's use the function of 2. So it will be 2 times our x here is 2 plus 1, which is 2 times 2, 4 plus 1, 5. What about function of, let me choose randomly, function of 4. So it will be 2 into bracket. What's our x? Is 4 plus 1, which is 2 times 4, 8 plus 1, which is 9. This is the formula that we use in deriving the codomain or in extracting the codomain from the domain. Now, what we really want to talk about here is not something that is very. So now let's talk, it's not something that is very long. So this f of x is equal to 2x plus 1. So is whereby this one is the image, is the one that provides the image, while this one is the function of x. That means what you input, the value you put inside here is what you get here. Like this function of 2, when you apply this 2x, when you apply this formula into this 2, you get this 5. When you apply that 2x plus 1 into these functions of 4, into this 4, you get 9. That means this 2x plus 1 is what? It is what we store inside these variables. For example, if you store a perishable food or if you store anything inside your fridge, so what you store is what we get. You can't store a beef or a milk inside the freezer, and the next day you want to take out your beef or milk and not turn to something else. No, it is garbage in, garbage out. What is what you put inside that you will get back. So therefore, or for example, you press 2 plus 2 in the calculator, it will give you 4. So it can't give you unless if the calculator is malfunctioning, if it's not performing very well, it is when it will give you wrong answer. So now here 2x plus 1, it is what? It is what is stored inside the what? Inside the variables here, inside the x here. So after storing there, we will now what? We will now press it out. This is what will give us. It will give us any value of this thing. So therefore, our fx is the same thing as y here. So, our y can also be 2x plus 1. So therefore, fx can also be, we can also write fx as y. They are the same thing. Either fx or y, they are the same thing because the function is the domain, y codomain is the y. So they are the same value. The function of x will give us the value of y. They are the same thing because in calculus or in some works, they can, or in some topics, they can use it vice versa. Either f of x or y, they are the same thing. So that is what a function is. A function is a mapping whose codomain is the set of numbers. And this formula for getting our codomain is what will input, is what we put inside these functions to get our codomain. And if our codomain is a number, if everything here is a number, that means this whole mapping is known as a function. So that is it. Now move to the question of the differentiation from the first principle that we want to deal with.